Let's get started on Module 2, Introduction to Virtualization, the Software-Defined Data Center. In this section, we will discuss what is virtualization, why do we use virtualization, what are the components of a software-defined data center. We will do an overview of ESXi hosts, and we will look at vSphere user interfaces. Let's start out with the introduction to virtualization. Virtualization is the foundation of cloud computing. And I think everybody knows what cloud computing is. It means computing over the internet. An example of cloud computing would be a user at a smartphone or a laptop computer connects over the internet to a cloud server and runs applications on the cloud server. VMware vSphere is the software that runs the cloud servers. Virtualization is the foundation of computing, and VMware vSphere runs the cloud servers and the data center servers. The name of the company is VMware, and the software is called vSphere. VMware vSphere is the software used to manage and control large data center servers and cloud servers. It's a lot like Windows 7. Windows 7 is not a computer, it's a piece of software. It's an operating system that allows us to manage and control a single computer. Similarly, VMware vSphere is a piece of software. It is an operating system that allows us to manage and control large data center servers and cloud servers. Public versus private cloud, or another way to phrase it would be public versus private data center. And the question is, should you have your own data center or should you use someone else's? Now, here at the Community College of Baltimore County, we own our own data center. We manage the data center, we do the backups, we do the upgrades. Our employees can connect remotely, our customers, our students can connect remotely. And the advantage is we own it. We have total control over it. The disadvantage is the time and the labor and the cost required to maintain a data center. Conversely, let's look at a public cloud. Let's look at an example of a three-lawyer lawyer's office. And for them to manage and maintain their own servers would just be too much time and trouble. It would make much more sense for them to outsource, for them to put their web page on a public cloud such as GoDaddy.com. And that way they would not be responsible for the data center management. At CCBC, we use a hybrid cloud. Most of our stuff is on our own data center servers, such as the student grades. But we also have public cloud servers. For example, Blackboard is located on a cloud server. A hybrid cloud is where an organization makes use of both on-site as well as public cloud servers. But whether it's public or private, VMware vSphere is the software that runs the cloud servers. Now let's discuss physical and virtual architecture. In this section, we will discuss what is virtualization and why use it. But before we discuss virtualization, let's discuss non-virtualization. Let's discuss the traditional physical architecture whereby we have physical servers. In a traditional server-based network, we may have multiple physical servers. The user stands at the workstation and connects to the switch, which connects to another switch, which connects to the server room. And then in the server room, there are multiple servers. There's a file server, an application server, and a domain controller. And this is where we have a separate box for each server. This is the traditional server-based network. And the disadvantage with a traditional server-based network is that there is an inefficient utilization of resources. Here's the example. When we first set up our data center here at CCBC, we got 4 new computers, and each one had 4 CPUs and 8 gig of RAM, and at the time, that was a lot. So we made the first one a DNS server, the next one a DHCP server, the third one a file server, and the fourth one was our registration server. But once we got them all up and running, we saw that the DNS server and the DHCP server were only running at 25% utilization, but the file server and our registration server were totally maxed out. So the disadvantage is that we have an inefficient allocation of resources. Now, I just wish I could take my fingernails and pull the processors out of this server and put them into this server, but it's just not that easy to do. So the solution is to implement server virtualization, where we install multiple server operating systems on one big computer. Here at CCBC, we have an IBM Blade server. An IBM Blade server is as tall as I am. And this guy is pulling out something that looks like a lunch tray. And that lunch tray is a blade. A blade, each blade has 2 microprocessors and 4 gig of RAM. And a blade is kind of like a motherboard, and you know what a motherboard is. It's a circuit board which has microprocessor and RAM on it. Well, each blade has 2 microprocessors and 4 gig of RAM. So if you put in 32 blades, you got 64 processors, and that is a powerful server. So what we do to implement server virtualization is we install multiple server operating systems on one big computer, and each one of those server operating systems is called a virtual machine. The ESXi hypervisor is a piece of software that allows Blade servers to host multiple operating systems, and VMware makes the ESXi hypervisor. When we install ESXi on a IBM Blade server, we then call that an ESXi host. An ESXi host is a big server which has had VMware ESXi hypervisor installed on it. And then we can run multiple virtual machines on the ESXi host. Since different servers have different requirements, we can assign a different amount of RAM and a different number of CPUs to each virtual machine. We can assign 1 CPU and 2 gig of RAM to the DHCP server. We can assign 2 CPUs to the DNS server. We can assign 6 CPUs to the file server. We can assign 7 CPUs and 10 gig of RAM to the registration server. Can you do that? Assign 7 CPUs to one server? And the answer is absolutely. That's the whole point of getting VMware vSphere. It allows us to run multiple virtual machines on the ESXi host. With server virtualization, we have many servers or virtual machines running on the same host, and each server is assigned a different number of CPUs, a different amount of RAM, and a certain amount of disk space, and the advantage is efficient resource utilization. Let's compare the traditional network infrastructure to the virtualized network infrastructure. In the traditional network infrastructure, the disadvantage is an inefficient allocation of resources. We have one machine running at only 25% capacity, so really that's a waste of 3 CPUs. And we have another machine running at 100% capacity. It's totally maxed out. Inefficient allocation of resources. But with virtualization, we have multiple virtual machines running on one big ESXi host, and different virtual machines are assigned a different amount of RAM and a different number of CPUs. Additional advantages of virtualization include consolidation, power savings, and ease of upgrading. This is what our old data center look like. And every time we added another server, we added more cables, and it was a real mess. But the advantage of virtualization is that you install all of our operating systems on one big ESXi host. This eliminates server sprawl, it consumes less power, it consolidates the cabling, and it's easier to upgrade. Meaning, to upgrade an ESXi host, to upgrade a blade server, all you have to do is buy another blade and slide it in place. Other advantages of virtualization include speed of provisioning and agility, and we will talk about that later in the course. Now let's discuss storage area networks and virtual disks. We are going to compare the physical file system with the VMware vSphere VMFS, Virtual Machine File System. In the traditional storage method, the hard disks are located inside of the server. But with a storage area network, you have an external disk array, which is sometimes just called a box of disks, and it is connected to the ESXi host using a switch. And then the virtual machines can save data to the disks in the disk array. Now this is a simple example, one ESXi host and one disk array. This is a better example whereby we have multiple ESXi hosts and multiple disk arrays. With the VMware storage architecture, many virtual machines can share the same storage devices. Many virtual machines running on multiple ESXi hosts can all access the same data store. What's the difference between a storage area network and a production network? Well, I think everybody knows what the production network is. The production network is where the user's workstation connects to a switch, which connects to a network interface card, which goes in the ESXi host. The production network is used to carry traffic from the users to the virtual machines. Now, the storage area network is whereby we have a second network interface card in the ESXi host, which connects to a switch which connects to external disk arrays. And the storage area network carries traffic from virtual machines to the disk arrays. Storing data on a storage area network. The virtual machines on the ESXi host save data to virtual hard disks which are located on the disk array. So we've used this term virtual hard disks. Let's look a little more closely at virtual hard disks. And the virtualization of a hard disk is called encapsulation. A virtual hard disk is a single file which appears to the operating system as a physical hard disk. It's located on the VMS file system, which is located on the disk array. Many of you are familiar with the NTFS file system, which is used with Windows, or the NFS file system, which is used by Linux and Unix. VMware uses the VMS Virtual Machine File System. A VMFS data store is a logical volume which spans multiple disks. And a virtual machine saves files to a virtual hard disk. And a virtual hard disk is a file on the VMFS data store which is located on the storage area network hard disk. And I know that's kind of complicated, but we will cover this in greater detail in Chapter 6. Now let's discuss physical and virtual networking. Everybody knows what a physical switch is. It's a box that allows us to connect servers to servers, and it connects PCs to servers, and it connects everyone to the router, which provides our internet connection. Well, a virtual switch is similar. It connects virtual machines to virtual machines, and it connects virtual machines to the network interface card on the ESXi host. So let's look at the ESXi host. This box right here is supposed to be the ESXi host. And running in the ESXi host are multiple virtual machines. The ESXi host has a physical network interface card in it, and that connects to the physical switch, which connects to the user's workstations, and which connects to the internet connection. So how can all of these different virtual machines connect to this single network interface card? And the answer is a virtual switch. A virtual switch is a piece of software that's used to connect virtual machines to virtual machines, and to allow virtual machines to connect to the physical network interface card in the ESXi host, which connects to the physical switch, which connects to the workstations and the internet connection. A virtual switch is a piece of software that connects virtual machines to virtual machines, and which connects virtual machines to the physical network interface card on the ESXi host, and we will cover virtual switches in greater detail in Chapter 5. So, in summary, virtualization. A non-virtualized environment is what we call the traditional server-based network infrastructure. It's where we have separate physical servers, which can be extremely inefficient. It's where we have disks, which are located in the servers, and it's where we have switches to hook them all together. But with the virtual network infrastructure, and this is what they call the software-defined data center, we have virtual machines which run on an ESXi host. The virtual disks are stored on the storage area network, and the virtual switches connect the virtual machines to the network interface card in the ESXi host. And this concludes Part 1 of Module